In this video we will see how to process a sorting NMR using the Mestrenova program. The procedure is basically the same as the one for the proton NMR, although there are small differences, and also we will see here how to process a DEPT and overlay both spectra in the same page. So first of all, we have to browse for the folder where we have our spectrum. Let me have a look for it. Here it is. We're going to process the sorting NMR for limonene. So I have here a folder with all the data from limonene. We have here three folders. The number 2 and number 3 will be the ones corresponding to the carbon and the DEPT spectrum. So I open the folder, I select the FID from all these files here, and here is the spectrum from limonene. Remember that we can increase or decrease the intensity of the signals by picking in these two icons, and we can do that also using the wheel of the mouse. And then the things that we have to do, like in the proton NMR processing, are first the correction of the phase that we do with this icon here. We select this icon and we say manual correction. This time we have a pretty good phase baseline, but it might happen that our baseline is distorted like this, and in that case we should go to the phase correction, say manual correction, place the mouse on top of this pH0, press and drag until we place the baseline in the correct way. So now we have the phase corrected. Remember also that in the proton NMR we can also make expansions by picking in this magnifying glass symbol and picking and dragging, and we can recover the full spectrum by selecting this tool here. There is the full spectrum again. The second thing that we have to do to process a sorting NMR is to reference the spectrum. This is to give a particular value of chemical shift for a signal. Usually in the sorting NMR, if the spectrum is being taken in chloroform, we use the signals of the deuterated chloroform. So I expand this area here. The signals of identical intensity correspond to the solvent to the deuterated chloroform. I go here where I can see this symbol that says TMS, tetramethylsilane, and then I have this red line. I place the red line in the center signal of the deuterated chloroform. Now I select solvents and look for deuterated chloroform. This is the chemical shift for the central signal of deuterated chloroform, and I have now the signal adjusted in the proper place, which is very close to 77 ppm. I recover the complete spectrum, and the only thing that is left here is to have the list of the peaks. To that I go for this tool, which we have like a tweezer picking a peak. I select manual, and I can select all the peaks that I want, which will appear all those that appear over the line that I'm selecting here and here. And of course I don't want the signal of the deuterated chloroform to be listed. Finally, all I have to do is to select the area I want to plot. Could be, for instance, from 220 to nearly 0, adjust the intensity to what I desire, and that will be it for the moment. There are some other things that we can do with our spectrum. For instance, we can introduce text, we can introduce drawings, but we can also paste things that come from other programs. For instance, I have here limonene and I have drawn with ChemDraw. I can say copy, and here we have an option to paste ChemDraw drawings. So here now we have the structure of limonene. I can move it to the place that I want. and then I again leave the spectrum in the size that we may want. I could simply print or export it to a PDF file. If you remember, in our original folder for the data of limonene, we had 3 different folders. Folder number 1 will correspond to the program, number 2 to the C13 NMR, and number 3 corresponds to the DEPT-3 experiment. So let's see how we process the DEPT-3 experiment together with the C13 NMR. So we open this folder, we select the FID file, and you can see here how we have some signals which are pointing up and some signals which are pointing down. And this is the typical thing for a DEPT experiment, in which we have this signals for CH and CH3 carbons pointing in one direction, signals for CH2 carbons pointing in the other direction, and we don't see the quaternary carbons. So what you have to do here is to decide which signals are going to put pointing up and which one are going to put pointing down. For that, we have to think about the structure of limonene. In this particular case, we can see the spectrum of limonene that we already have there by selecting here C, pages. You can have a look at the limonene. We have the structure pointed in here. You see that we have some methyl groups, some CH2 signals, and also some CH signal here. We may think that these 2 signals, which are at lower chemical shift, might correspond to the methyl groups. That makes sense, and if that were the case, in our DEPT experiment, these 2 should correspond to methyl groups. So let's put it pointing up. This is how we got it, so this is fine already. If we wanted to change it, we should go here to the phase correction. Select manual correction, go here, place the cursor on top of these bold characters, and pick and drag. Now we can change the signals are pointing down, are pointing up, and so on. But this is not the way we want to paint it. We want it to put it in the original way, which was this one. So this is fine. The methyl group should be pointing up, the others will be pointing down. When we don't know that, we might have to guess which is the right way to put them. So this is the DEPT experiment. The other thing we need to do here is to reference this spectrum to decide the chemical shift, or to assign chemical shift for one particular signal, so that all the other signals will be established related to that one. So let's go again for the C13 NMR. Let's have a look, for instance, at this signal here that appears at 41.22, and we can go here and select the same signal and give the same chemical shift. So we go to TMS, pick in the signal, and put the value. We don't say solvents here, we just put here 41.22. Accept, and we have now exactly the same chemical shift for the C13 NMR than for the DEPT. So now we could go ahead and plot this experiment, this spectrum, if I feel like. The other thing that we can do is to plot both the spectra, one on top of the other. To do that, what you have to do is to select both of them. First, we select them just by picking in this area here on the left. We select first the one that we want to be plotted below, and we will select the second, the one that will be plotted up. So first we select the C13 NMR. Now pressing the Shift key, I pick on the other one. I have selected both, and then here in the left we have this symbol here that is useful to pile the spectra. And see, I have both the spectra, one on top of the other. This is the C13, this is the DEPT. This is useful because now I can compare very easily the signals in the 2 spectrums, so I can see clearly these are quaternary carbons, this will be a CH, this will be a CH2, and so on. There are still some things I want to fix in this spectrum. For instance, we have here this vertical scale that I don't like, So I can get rid of it by going here into Properties, Scales, and you see that we have here selected the vertical scale. This will be the horizontal scale. We select the vertical scale. We unselect this and see that we don't have the vertical scale anymore. Second thing that I really don't like in this case are the colors that we have. I rather put everything in black color. For that we go to Spectrum, we say Common, and here we can change the colors. For instance, say everything will be black, and now I have the whole spectra painted, everything in black, and now I can expand it in the way that I want, and this is the spectrum that we have. We could still probably paste again the structure of the limonene, and now for some reason I lost my expansion. I put here the expansion again, and I go here and I say export PDF, and I will have the PDF of the spectrum. I will see it now in a moment. Now this is what we get from the PDF conversion. So basically it's exactly the same thing that you can see in the screen of Mestrenova.